Okay, so we'll process cardiac perfusion scan. The data acquired is the CT for the rest, CT for the stress, and then rest gated.
CT data is mandatory here.
Yes, CT is for the attenuation correction and the scatter correction.
Without that, it will not process.
Yeah, processing is possible, but the corrections like attenuation correction and scatter correction will be done if CT is there.
Okay.
So we have four spec data sets here: rest gated, rest tomo, stress gated, and stress tomo. So let's select all the data together.
And what is the difference between the CTAC 5M R gate and rest gate and stress gate?
Yes, yes.
So in both the conditions, CT data is required, or the same
So
data
if we can process with single CT also,
okay.
but there you will require lots of registration check. But if you have two data sets, the registration interaction, like adjusting the registration requirement, will be less. So
during acquisition, this process is
ideally,
already
yeah,
acquire two CTs.
Two CTs, yes, because the CT is very low MA CT, just 30-40 MA, just for attenuation correction. And select both the data sets, go to the cardiac section. Here we have three softwares for processing perfusion scans: Emory Cardiac Toolbox, MyoAsian, and MyoAsian Evolution. So MyoAsian and MyoAsian Evolution is GE software, whereas Emory Cardiac Toolbox is a third-party Emory University software. So you can use, because the different parameters, different quantitative parameters are available in Emory Toolbox. That is not there in MyoAsian.
So this one is advanced one, or it is?
Yeah, this is the latest Emory software.
So MyoAsian, the Emory is better than the MyoAsian, you mean to say?
Yes, so you can get more information, quantitative information in Emory compared to MyoAsian. MyoAsian will provide only the perfusion images and polar map scores, whereas and the ejection fraction systolic volume. Whereas in Emory Toolbox you can get the peak filling rate, peak emptying rate, the diastolic dysfunction, then phase analysis within the Emory Toolbox, which is not there in the MyoAsian. So let's start with the Emory Cardiac Toolbox. Single click, the software jumps to this end, and let's start with the left screen. In the confirmation, data users confirmation dialog box, you need to select the study type, whether it is 1 day, 2 day, thallium, dual isotope, tetrophosphine. So if rest study is done first, we need to select 1 day. So as in this study we can see the time here. So rest is acquired first, followed by stress. So let's select 1 day here and then click OK. Software will automatically calculate and try to detect the heart position and automatically reorient the initial slice limits. So you can see it has perfectly aligned the slices, but still if you think it has to be realigned manually, you can do it. Okay, so now next step is to do the attenuation QC. So first click on this any image of from the stress and click attenuation correction QC and proceed. Now here you need to check any misregistration between the NM and CT. We need to ensure that this red border should not go and touch the ribs of the bony areas, and also it should not go to the black area, that is lungs, because if it goes to the ribs there will be more attenuation correction factor will be applied, and if it goes to the lungs area there will be negative attenuation correction factor. So we have to reposition it, and these are the tools for the re-registration. And you had different ways of displaying the images. One is the organ mode, where we can see sagittal short axis, vertical long axis. Other way is the body mode, where you can see the coronal sagittal. So anyone you are compatible you can use for re-registration. So these are the arrows. Like I want to shift the CT image little bit towards left, so I will click this left arrow button. Now you can see all other getting adjusted. This one I want to shift little bit on right, so image should move to little bit left. Right, next step is just scroll and see. Okay, so registration is done. Click proceed. Similarly you have to do for the rest study. Click on any image and then click proceed. Click on adjust registration. Here also we can shift little bit downside, and image should shift little bit on up. It's better.
Yeah.
So this one is, you have to check this side. I think it should move little bit this side. Okay, then click proceed. And this is the review tab. Click on the review tab, automatically it will re-slice. So here it is saying that select the right database. So there are different databases here.
So again, why it is asking for the database check? Because already we have assigned the data set.
Yeah, so what you have selected is a rest and stress, but here you have selected one day, but one day there are different types of different ways of doing one day scan, like with attenuation correction, without attenuation correction, and with low dose, high dose, with treadmill exercise, pharmacologic stress. So different ways you have to select the database which is exactly matches to your study. For example, this study is suppose standard dose, rest and stress with attenuation correction. So you can see this one AC, instead of, if you are not using ACT, then you need to select this one, right?
Okay.
Otherwise this one with AC. So that's why it is asking you, the software can detect like you are performing attenuation correction. So you have to select the proper gender. Alright, then click proceed. This is the screen which is editable if this external ROI is not at the proper place. Sometimes maybe like this. So what you have to do, just place it correctly as it is now. Okay.
So it seems fine, I think.
Yes, so it has to be like this. So most of the time the software can handle this thing.
Okay.
If you want to show the borders, like there is no extra activity it is detecting, so you just probably check. Then next option is to see the slices.
Can we go to the previous step?
This one.
Yeah. So what are the parameters for setting this apex and this basal ROIs? Is there any rule for that where we should keep?
So this is mostly related with the polar map which you are going to get. So polar map has to be from the base to the apex, and this stress and rest should match. Like there are 10 4 to 16 slices, here 5 to 16. So this you can adjust and make it 4
to 16.
So both will be exactly same. Then slices, here you can see these slices, and you can click and can see the 4th, 5th, 6th, everything is matching perfectly, right?
Okay.
That is the advantage of having that automatic reorientation software. So that was not available in the older version of Xeleris, which is there in. So in Xeleris 5 it is fully automatic. So anybody can process cardiac now, and everyone will process same.
Okay.
So this is the polar map. Here it calculates the scores, severity score, and 0 reflects normal, and there is 0 to 4 categorization. 4 is means fixed defect.
So manually it can be modified.
Manually also can be modified if you think the software has not done it properly. Okay.
Okay. So I think the manual changes comes in a rectangular.
So if user is modifying it, suppose user thinks that there is some defect, they can assign it. Then it will show in the square box just to indicate that it is modified by the user. Okay. Otherwise it won't be able to differentiate whether it is computer generated or manually changed. Here is an option on the top. Suppose this is the NAC images. If you want to see the AC images, you just click on that AC tab. Then you can see this header color is changed. So yellow means attenuation corrected images. So what is the effect? It is mostly improvement in the inferior wall. So if the patient is obese or female patients, it is advisable to use the CT attenuation correction. You can see that the score is 0 and the inferior wall has improved. If you go back to this, you can see here reduced, right? But still it is showing 0.
Yes.
So that is the advantage of this software. If you process in the old software, it will show some defect here. But having a normal database and you have selected the right database, then it can calculate it more accurately. Then next is the polar maps and stress severity score. You can see all attenuation corrected data, and there is no defect except this one, right, which has it is scored as 2.
It shows percentage uptake.
Yes, exactly. So percentage uptake, or you want to see the score. and if you want to show the ratio, ratio means normalization based on the activity injected.
Okay.
So in the stress, suppose you have injected whatever activity you have injected, you have to just enter it and then you will get the normalized values. For example, if you inject the first scan, suppose 8 millicurie, this will be 24. Rest is done first, so this one will be 8. राइट अभी ठीक है. और इसमें अगर ऑल इज कमिंग ब्लो, रेशियो मीन्स इट शुड बी सेम, राइट. इफ जैसे 3/3 शुड बी 1,
It should be near to 1.
exactly. So it has to be blue areas. That means there is no difference in the stress and rest. Suppose there is a triple vessel disease, balanced disease, then this will show uptake.
Okay.
So in that, and this score you will see high ratio. Now you see here it is
more than 1.
Near 1, right?
In that case it will be more than 1.
In that case it will be more than 1.
Okay.
Next is extent of the defect for each territory. So these are the only one defect is there, this one, and total defect it is has calculated 2% of the total LV. Total LV का 2% is defective, but LED में LED का जितना एरिया है, this area, उसका this is 5%.
Okay.
And there is no defect in the other two territories, LCX and RCX.
Fine.
Okay, so this one is showing reversibility. यहाँ पे कुछ भी इम्प्रूवमेंट नहीं हुआ है, राइट. जो इतना डिफेक्ट इधर है उतना ही इधर भी है. देयर इज नो इम्प्रूवमेंट, दैट इज 0% इम्प्रूवमेंट.
So that means there is no reverse.
देयर इज नो रिवर्सिबिलिटी. दिस इज शोइंग इट इज ए फिक्स डिफेक्ट. जितना पार्ट रिवर्सिबल रहेगा, जैसे ये सपोज 5% है, समझो LED का 5%, तो ये 5% अगर इसमें थोड़ा इम्प्रूव होता है रेस्ट में, सपोज इट शोज 2%, सो दैट मीन्स अगर ये 2% दिखा रहा है, मतलब 2% उसमें इम्प्रूव हो रहा है, 2% रिवर्सिबल है. ओके, देन यहाँ पे लेबल रीजन है, इफ़ यू वांट टू लेबल इट. ओके, देन फंक्शन. Filter में there are two options. If you click none, you can see image becomes little noisy and the movement is not that good, right? So there are two ways. One, temporal. If you select temporal filtering, you can see there is a rhythmic movement, and spatial also. If you select both, you can see there is a proper visualization of the movement. Now these are this LO1 is the EF graph, and this one is the rate of change of rate change, right?
Okay.
This is the LV volume divided by time. This is only volume, right? Volume versus the frame number, gate number, bin number. But this one is the LV volume divided by in seconds. So this becomes rates. So you can calculate that at what rate the LV cavity volume is changing. So this information you will not get in the other softwares, MyOcean or MyOcean Evolution. This one, peak filling rate, time to peak filling rate index 4.99, and the heart rate. This polar map shows the thickening of the walls. If there is a good thickening, there will be these will be white color. So white color indicates what? Thickening. 40%. Thickening of the wall. So if the thickening of the wall is good, that means it is a good myocardium. Okay, normally if there is a ischemic or fixed defect, then thickening doesn't happen. Okay, so these are the colors. So like here the thickening is in this zone and this zone is here, right? But the white is the good thickening. Then desynchrony, top images are for the stress and this is for the rest. You can see there is a good peak. So narrow is this peak, better is the LV movement.
Okay.
Then LV phase guidance. Okay, ये जो फंक्शन वाला रहता है ना, ये हमेशा NAC में ही रहता है. ये वाला स्क्रीन में आपको AC वाला इमेज नहीं मिलेगा. फंक्शन के जितने भी है वो सारे NAC डेटा पे ही कैलकुलेट होते हैं. ये भी इसीलिए जब आप इसमें जाओगे यहाँ पे तो यू विल सी दिस ऑप्शन, राइट. यहाँ पे आप चेंज कर सकते हो. बट आप जैसे ही इधर आओगे, हाँ इसमें भी है, फंक्शन में जैसे ही आओगे वो डिसअपियर हो जाता है. देन वाइबिलिटी, अगर आप FDG स्कैन भी करेंगे ना तो just select the proper normal database, you can see the viability and it will calculate the how much myocardium is viable with FDG scan also. Then 3D images, and there is a report generation software, and if somebody is interested to write the report using this software itself, they have to enter all these patient details, all the clinical history and the protocol you choose for the scan, and then the baseline EKG and all ECG, all the details, then stress, perfusion defects, all that will be detected automatically by the software, and wall motion and thickening values will be displayed, and automatically the software will generate this comments and this thing software. And then if you click on the final report option, you can generate, and it can be edited also. And then it can be exported if you want to export to any external as an image or as a movie.
So which one, this 3D image?
Any image, any screen, whichever screen you want to transfer. For example, suppose this function. Suppose you want to send this screen, you just click export.
Okay.
Only motion you want, or you want to include all this study info, you can choose it. Okay. यहाँ पे ऑप्शन है टिप्पा MP AVI है, राइट. AVI मीन्स वीडियो. जिप भी बना सकते हो, BMP PNG. ओके,
एनिमेटेड जिप.
हाँ वो देखना पड़ेगा क्या आता है उसमें. तो फॉर एग्जांपल ये AVI जनरेट करते हैं, एक्सपोर्ट.